everyone. This is Jia. This is my second paper review. Today I'm going to talk about a deep learning iris recognition method based on capsule network architecture. So previously I talked about using the fingerprint as a biometric to identify a person. But this time we are going to talk about the iris recognition, which is also very common. So iris recognition is unique, stable, and non-invasive. And the capsule network was proposed in this paper in 2016. So it can learn and store spatial relationship information on the whole parts and the local of the object. It has the advantage of anti-noise, so it's very stable. Also, it has a global feature learning, equivariance mapping, robust training, and confidence assessment, and overlapping object detection. But the research on capsule network is in iris recognition is very rare. So here are the three types of the dataset they used. So there are three datasets. The first dataset represents the dataset with few categories and few samples. And second row is the second type of dataset, which represents the few dataset with few categories and many samples. The third one represents the dataset with many categories and few samples. So here is the machine learning pipeline. As we can see, the network pre-trained, they use the VGG16, ResNet 50, and Inception with 3. So those networks are pre-trained and then fine-tuned. And they also have other 3 networks. So those 3 are Iris Dance, DRDL, Iris Inception, DRDL, and Iris SE, DRDL. So those are the shadow convolution network, and they are fully trained. We also have the 3 baseline model. So those 3 types of model are from the previous literature. So they will compare those later in the paper. So in this paper, so previously they talk about the dynamic routing algorithm. So they use the single cosine similarity of 2 vectors to measure the agreements, but it's difficult to converge. But in this paper they propose something called the DRDL algorithm. So they combine the direction and length of the capsule as the evaluation index of the similarity of 2 vectors. So they said the DRDL has a higher accuracy than the dynamic routing algorithm. Also, they converge faster. So here is 3 tables that summarize the model performance. So the pre-trained model substructure combined with the dynamic routing algorithm, the networks are able to converge in the training process. So the performance was not great. But the problem is solved when they are using the pre-trained models with the DRDL. And the dynamic routing algorithm works well with the fully trained channel works as well, but it's incompatible with the pre-trained model substructure in the dataset. So additionally, they also did something called the simulation of the light intensity. So they said previously this was really done in the iris recognition. So in this simulation, they assume the model is trained only in the strong light and then validate in the weak light environment and vice versa. So the simulation, they use the images from the GLEV4 dataset because the dataset has varied light intensity. So they compare the 3 baseline model. So those types of model, they are convolutional network without vector structure, which are 12-layer CNN, VGG16, and Inception with 4. And they also did the simulation on the 3 networks with the vector structure. so the Capsule network, VGG 16 5 blocks DRDL, and the Inception Way 3 6 blocks DRDL. So they conclude that the accuracies don't decrease much for the networks with the vector structure. So conclusion, so the deep network with Capsule network is very good at iris recognition, and the network performance with pre-trained model structure as convolutional part is more stable than using the shallow fully trained convolutional structure. Also, the simulation experiments show that the network with the Capsule architecture are more stable and has a higher accuracy than the network with CNN, the baseline model. So the future work, they want to explore other vector forms and the vector structure in the model. Also apply Capsule feature learning network to deal with iris recognition problems of heterogeneous iris and other specific environments. Also, they like to research network processing capacity and processing methods when the number of categories becomes extremely large. So here's what I think. So things I like, I think they do a very good job in explaining the baseline model. Also, they did a lot of comparison of the pre-trained and the shallow convolutional networks. However, since they propose a new algorithm called DRDL, I think it's better if they, do more explanation on that. Also, maybe it's better if they give like a specific example on it. Also, since they did so many comparisons, but they didn't show the result of the poor performance model. Also, because the second and third data set are large, so they have to select like a subset of the data set. So I think it's better if they mention how they select those subset. Is it based like a random state, or maybe they pick by hand or something. So that's all I have. Thank you so much.